Meet UY Scuti, the biggest star in the universe. Its radius is 1,700 times bigger than that of our Sun. But to set this record, the star had to sacrifice its brightness. Its luminosity is just 340,000 units, while the luminosity of the brightest stars is measured in millions of units. People on Earth see UY Scuti this way. Not so impressive, is it? The biggest star in the universe shines in our skies no brighter than Proxima Centauri, a red dwarf. And as if that's not enough already, astronomers recently found a new giant star that can dethrone UY. In this video, you'll find out how many years does it take to become the hottest star in outer space, how fast can you fly around a supermassive black hole, and what do stellar record breakers have to sacrifice to become the champions of the universe? Why isn't UY Scuti the biggest star in space anymore? Scientists discovered it back in 1860, but finally determined its size only in 2012. It turned out that UY Scuti is so huge that it even takes light 7 hours to travel around it. By comparison, you'll need just 14.5 seconds to circle our Sun at the speed of light. And if we replace the Sun with UY Scuti, its boundary would be running along the orbit of Jupiter. However, the star wasn't in the lead for too long. In 2020, the title of the reigning champion was handed over to another giant called Stephenson 218, located nearby in the same constellation of Scutum. This enormous star has enough room to fit 10 billion of our suns, and its radius is 2,000 times larger than that of our little yellow dwarf. But why did UY Scuti lose the race so quickly and easily? The point is that its incredible size dramatically reduces the star's density, so it masses no more than 7 or 10 of our suns. And that's a real problem. Its gravity is too weak to keep the star's outer envelope in its place. That's why UY Scuti loses 5,800 thousandths of a percent of a solar mass every year. At the moment, it burns faster than any other star in the universe, and Stephenson 218 is going to suffer the same fate. But here comes the plot twist. These are not the worst problems that giant stars have to deal with. R136A1 is the most massive star in the universe. It's as heavy as 315 of our suns, and it shines almost 9 million times brighter than our star. Researchers at the Argelander Institute for Astronomy in Bonn have figured out that R136A1 was once a cluster of small stars in the Tarantula Nebula. As time passed, they merged and formed a massive blue giant. But a huge mass isn't only about benefits like unrivaled luminosity, it's also a big headache. The surface of R136A1 regularly ejects matter into interstellar space, and it does that with such force that the star's habitable zone lies at a distance of almost 3,000 astronomical units away from it. To make it clearer, keep in mind that the habitable zone of our solar system lies within 1 astronomical unit away from the Sun. But the most important thing is that because of its large mass, high temperatures inside R136A1's core quickly produce metals, iron, nickel, and zinc. This means that this star will develop an iron core earlier than other bodies with the same characteristics. It seems that instead of eventually becoming a supernova, R136A1 will turn into a black hole at the end of its life. It doesn't sound promising, but even this is not a big deal compared to what a star in the Sagittarius A cluster has to put up with. How do stars survive if they orbit the supermassive black hole in the center of the Milky Way? And yes, stars like that do exist. The first one that attracted the attention of scientists was S2. For a long time, it was considered the closest star to a black hole ever. Then, in 2019, a group of astronomers led by astrophysicist Florian Peisker at the University of Cologne, Germany, discovered S62. It waves hello to a supermassive black hole from a distance of just 2.4 billion kilometers. That's less than the gap between the Sun and Uranus. S62 was thought to be the fastest star in our galaxy. The black hole's gravity makes it speed up to 20,000 kilometers per second, which is 6.7% of the speed of light. However, S62 was soon beaten by its close neighbor. In 2020, Peisker's team spotted S4711, a blue star from the same cluster. It's situated farther from the black hole. The minimal distance between them is 21.5 billion kilometers. Despite this, its speed reaches 7% of the speed of light. S4711 needs only 7.5 years to complete one revolution around the supermassive black hole. Traveling at such a speed, this star would make a full circle around our sun in less than a day. But guess what? That's right, this achievement has also now been outshone by another competitor, S4714. It moves along a very unusual extended orbit and comes within 1.9 billion kilometers of the black hole. And that's an absolute record, people. Its speed reaches 24,000 kilometers per second, which is as much as 8% of the speed of light. But the title of the fastest star comes at a price. S4714 orbits Sagittarius A, a giant black hole in the center of the Milky Way. At any moment, it can blow the star to bits or drag it beyond the event horizon. But it looks like S4714 is going for broke as it keeps moving at incredible speed. And for the next record holder, this one is doomed for sure. In this photo, you can see not only a nebula, it's the stellar wind and stellar substance that erupts from the hottest star in the universe, Wolf-Rayet 102 from the constellation of Sagittarius. Its surface temperature is 36 times higher than that of our Sun, 210,000 kelvins. At the same time, this star is very small. Its radius is half that of our Sun's radius. There are only 10 known stars of this kind, and 4 of them can be found in our galaxy. In truth, WR102 is in the final stage of a massive star's existence. Its record temperature is the result of nuclear fusion and helium burning. WR102 used to be a giant star of around 40 or 60 solar masses. To date, it's run out of most of its fuel and now weighs a bit more than 16 of our suns. Scientists have calculated that WR102 will explode and become a supernova in 1.5 to 2,000 years from now. Thank goodness that our solar system's only star has such a boring life. Just imagine what could happen if our sun suddenly decided to go into the space record books, say by achieving the highest speed ever, for example. So tell me, would you like to live near a star that revolves around a supermassive black hole? Leave a comment to let us